So today, the student will be able to describe the end behavior in zeros in order to describe the graphs of polynomial functions. So remember for a second that the end behavior, we haven't really said that out loud, but the end behavior is what happens to the graphs as they go left and right. So what happens on the end of the graphs, what happens on the end of the left side and the end of the right side. The zeros, are the x-intercepts. Okay, so first of all, we have this huge chart that kind of gives us all the possibilities. So the first thing we need to look at is the degree. If the degree is an even number, okay, so the degree, remember, is the biggest exponent. If that biggest exponent is an even number, then your end behavior is going to be the same. So you see how to the left, my graph ends going up, and to the right, it ends going up. Or to the left, this one goes down, and this one goes down. So the ends of your graph are going to go the same direction, either both up or both down. And we can say that by describing it this way. So the end behavior, and this looks kind of weird, but basically here's what we're looking at. As x approaches negative infinity, well, your x's approach negative infinity when your graph goes to the left. So basically we're just saying as we go left. So if you ever see as x approaches negative infinity, it always means the same thing, as we go left. As you go left, the y values, remember f of x is y. As I go left, the y values are going up. So the y values are approaching positive infinity. That arrow means approaching. So as x approaches negative infinity, as we look to the left, the y values are going up, so they're approaching positive infinity. As x approaches positive infinity, that's another way to say as we go right. If you ever see as x approaches positive infinity, you're just going to look to the right of the graph. And as the graph moves to the right, my y values again are moving up. So the y values approach positive infinity. Okay? Looking down again, so if the degree is an even number, that means my end behavior will go the same direction. So as x goes to negative infinity, as we look to the left, the y values, so as we go left, my y values are going down. So they're approaching negative infinity. As my x values approach positive infinity, as I move to the right, so as I move to the right, I look and my graph is moving down. So if you have an even degree, then your y values will have the same end behavior. They're both positive infinity, or they're both negative infinity. So an even degree means you have the same end behavior, okay? An odd degree, your degree is odd, that means your end behavior is opposite. So our end behavior So if you look here, as x approaches negative infinity, that means as I look to the left. As I look to the left of my graph, I notice my y values are going down. So your y values are approaching negative infinity. As x approaches positive infinity, meaning I'm looking to the right, my y values are going up. So the y approaches positive infinity. Okay, I have an odd coefficient in my end behavior is opposite. One is negative, one is positive. When you have an even degree, then your end behavior is the same. So again, underneath it, you have another odd degree. So that means that my end behavior should be opposite. So as x goes to negative infinity, that means as I look to the left, my graph is going up. So y values approach positive infinity. As x approaches, whoops, I don't know how I did that. Delete. As x approaches positive infinity, so as I look to the right, my graph is going down. So my y values are approaching negative infinity. So when you have an even degree, same in behavior. Odd degree, opposite in behavior, okay? Now, here's what the next thing we need to look at is our leading coefficient. So the leading coefficient, remember, is the number that is attached to it. It's the coefficient of the variable with the highest exponent with the degree. If the leading coefficient is positive, okay, that means your graph is going to end going positive. So the leading coefficient only tells us about the back side or the last part of our graph. So when the lead coefficient is positive, then as our graph goes to the right, we're going to have a positive y's. If the leading coefficient is negative, oh, that blue is too similar to the green. Let's go with a different color. Let's go with yellow. If the leading coefficient is negative, then that means your graph is going to end. So the right side of your graph is going to end going down. So the leading coefficient tells you what's happening on the end of your graph or the right side of your graph, okay? All right. Oh, excuse me. Okay, let's look at a couple. One more thing. So the only other thing we're going to look at is the zeros of your graphs. Remember, the zeros are the x-intercepts. So look at this note here. If you have an odd degree function, they will always have an odd number of real zeros. Even degree functions will always have an even number of real zeros or no real zeros at all, okay? So an odd degree, that was purple. So odd degree functions, an odd number of real zeros. So they'll have 1 0. They'll cross. That's really just like saying how many times will they cross the x-axis. So odd degree functions will cross the x-axis an odd number of times. They might cross once or 3 times or 5 times. Even degrees, even degree functions will always have an even number or no real zeros at all. So it is possible that an even degree doesn't ever touch the x-axis, or they will cross the x-axis an even number of times, 2 times or 4 times or 6 times. It is possible that you touch the graph twice at the same spot. If you touch the graph twice at the same spot, you touch the x-axis twice at the same spot, like x is 4 and x is 4, then you have what's called a 0 with multiplicity 2. So it touches that 0, it just touches it twice. That's kind of some extra information. Okay, let's look at this first graph. This first graph, the end behavior. As x approaches negative infinity, that means as I look to the left of my graph, I notice my y values are going down. So we're going to say the y values approach positive infinity. As x approaches infinity, so as we look to the right, again, my y values are approaching, oh, sorry, that was so wrong. The y values are going down, so they're approaching negative infinity. And as I go to the right, they're also approaching negative infinity. Okay, the degree. We know the degree based on the end behavior. Because the y values are going in the same direction, the end behavior is the same, we know that this is an even number degree. So this might be an equation that's x to the 4th or x to the 5th or x squared. The lead coefficient. In order to find the lead coefficient, we need to look at the end of the graph. So just the right side. Because the right side is going down, we know our lead coefficient is going to be a negative number. Okay? The number of real zeros. This particular graph has no real zeros. because it doesn't ever touch the x-axis. And that's okay, because even degrees will either have an even number of real zeros or they will have no real zeros at all. So this would be one that if I gave you the equation of this graph and you use the quadratic formula, you would end up with an I, because it doesn't actually have real solutions. It has imaginary solutions, okay? Extra information. All right, number 2. The end behavior as we go to the left. So as x approaches negative infinity, as it goes to the left, your graph is going down. So the y's approach negative infinity. Okay, as x approaches positive infinity, as we go to the right, my graph is going up. So y approaches positive infinity. The degree of this graph has to be an odd number. And it has to be an odd number because the end behaviors, the y's, are going in opposite directions. Okay, the lead coefficient, I only look to the right side of my graph. The right side of my graph ends going up, so the lead coefficient is a positive number. How many real zeros does this graph have? This graph is an odd degree, so it should have an odd number of real zeros. And if I look, it only touches the x-axis one time. So there's only one real zero, okay? And that real zero is where x is close to -2. It's not really exactly on -2, but it's close to -2, okay? And remember, we found the zeros by factoring things and then solving for 0. So just kind of think of that like back and forth relationship. All right, next graph. The end behavior as x approaches negative infinity. As we move to the left, my graph is going up, so I can say the y values approach positive infinity. As x approaches positive infinity, as I move to the right, my y values are going up, so I can say the y's approach positive infinity. Because the end behavior, the y's are the same, I know that this is going to be an even degreed polynomial. Because the right side of my graph is going up, I know it's going to be a positive coefficient. And the number of real zeros is 2. So I cross the graph somewhere at like -1.5 and +1.5. So I have 2 real zeros that occur at that number. Okay? The end behavior of number 4. So as x approaches negative infinity, as we go to the left, my graph is going down. So my y values are approaching positive infinity. As x goes to the right, my graph is going up. So my y values are approaching positive infinity. Oh, man, I said negative infinity on this top one, but I didn't write it. The y values are going down as we go to the left. Okay, the degree. It has to be an odd degree because my end behaviors go in opposite directions. The lead coefficient has to be a positive number. So this polynomial has to start with a positive number because the right side is going up. The number of real zeros is 3. This graph crosses the x-axis 1, 2, 3 times. So I have a real zero at x is -1, at x is 0, and x is +1. So there's 3 real zeros. Okay, that was just kind of a introduction to if I gave you a polynomial, what would happen to its graph? Or from the graph, what could you say about its polynomial? So you're going to take this idea. You're going to do an assignment today that's in Canvas. Well, it's not in Canvas. You're going to email me your answers. But then after that, you're also going to do a Desmos assignment that I really just want you to explore, okay? But that's it for our notes today.